Hi there, Serdar Yegulop here for InfoWorld at IDG. In this episode of Smart Go, we're going to take a look at the map data structure in the Go language. Most modern languages have the concept of a map, a container or data structure where you could store values, some instance of an object, and then look them up quickly by way of a key, itself another object or value. Java has this in the form of hash maps, and in Python they're called dictionaries. In Go, they're simply called maps. The way maps work in Go is a little more constrained than in, say, Python, which has a lot of flexibility in terms of what you can use for keys or values. When you create a map in Go, you have to declare in advance what types will be used for the keys and what types will be stored as values. Here's one simple example of a map type declaration, where the keys are integers and the values are strings. We use map, followed by the key type in brackets, and then the value type after that. Now that we've defined a variable with the map type this way, but we haven't initialized it. And to do that, we can do one of two things. One, we can use the make function in Go to initialize an instance of the defined type with nothing in it. We can then add elements to the map one at a time by using the element adding syntax. The map variable, the key in brackets, and the value to add on the other side of the assignment expression. The other thing that we can do is use Go's literal syntax to create the object and populate it with data. We just provide a comma-separated list of key-value pairs, with a colon separating the key and the value. Note that when we use the literal syntax, we must have a trailing comma after the last item in the curly braces. This is a quirk of Go's syntax. When we create the map, we can access elements in it by using the key like this. We've already covered adding elements to a map, but if we want to remove elements, we use the delete function, where you supply the name of the map and the key to remove. Note that delete operates silently. It doesn't return an error if the key doesn't exist. It doesn't return anything to indicate that a delete was in fact successful. If the key doesn't exist, it simply does nothing at all. To check if a key exists, we can perform an operation like this. We attempt to retrieve from the map with the key and obtain an exists value to go with it. This is essentially a variation in the standard error reporting technique that Go uses, although in this case, instead of returning an error, it's returning a success value. So to iterate over everything in a map, we can use this construction. Range produces each key and value in the map, which we can then iterate over with for. We can also print out the entire contents of the map by just passing it to one of the print functions in the format library. Note that you should not rely on the insertion order of elements in a map. That is, you shouldn't assume that just because you insert something first into a map, that it will show up first when you iterate over the map later. It's easy to believe this if you print the contents of a map and have it show up in a certain order, but that's because the format package prints maps in a key-sorted order for the sake of making testing easier. In future installments, I'll explore some more advanced techniques for the use of maps. For instance, working with maps in JSON. This is something we touched on in a previous video, but it's worth exploring in greater detail. That's it for this time. If you liked it, please leave a comment below. Don't forget to subscribe to the IDG Tech Talk channel on YouTube. And for more Dev with Serdar and more Smart Go, be sure to follow me on Facebook, YouTube, and Infoworld.com.